Good evening, this is Dr. Atterberg, and this presentation is an introduction to RoboDK. RoboDK is an industrial robot simulation and offline programming, which we will be using in MET 415. The objective is to download RoboDK software tool to learn how to set up a robotic process station and to learn how to simulate a simple pick-and-place operation. The procedure includes 10 steps. We'll download the software tool. We'll create and save the process scene, which is called the station. We'll then upload the robot, the tools, the grippers, the parts. We'll set up the reference frames. We'll teach the robot position with respect to the reference frame. We'll write an auxiliary subroutine as an example to reset the process. We'll write the main program of the pick and place. We'll simulate the process, record it, measure the cycle time, and write a report. To download the software, we click on this icon right here, and you bring it into your personal computer. To activate the license, you will need a server code, which you'll get separately. You'll feed it into this window for the network system, and then you'll wait a few minutes, 10 seconds, and get started. Once you upload it, you'll see an icon on your screen, and when you click on it, you come right into the main RoboDK workscreen. The initial view is the reference point for the robot is given at the center, and we use this as a starting point to fill in the objects. To fill in the object, we click on this globe menu. We see a list of items. We'll bring in ABB IRB 120-3/0.6 to the scene. Then we'll click a table, we'll just find it and download it, and they go right into the scene together. You will see the ABB shown over here on the list, and also the table. You go on and click the part. The part is not shown over here, it's buried on the same reference frame. We'll bring it in a minute. So once we get the parts in the scene, then we set up the reference frame. To get a reference frame, we click on this icon right in here, and it will position the reference frame somewhere in the scene. We can then drag it and place it anywhere we want. Once we have the reference frame in position, we can bring in the part as a child for a reference frame. We can rename it. This one, the left side, as a pick reference frame, the right side as a place reference frame, and we'll make the part a child of the pick reference frame to get started. The next step is to teach the robot the positions in order to do the process, and in order to teach the robot the position, we can jog it by clicking on this icon right in here. This icon right in here will allow us to jog the robot along the axis of the reference frames to wherever we want it. Our first teach point is the pick approach position, and then once we jog it to this position, then what we do is we click on this icon, which is the target position, and we can change the name to call it pick approach. Then we bring it down nicely to the part, and we click again and rename it as a pick position. Once we're done, we can do the same for the place position. We come to the approach position over here, jogging, and click on the target point. We define it as place approach. We go down to the place position, we click the target, and then define it as a place. Once we have all the robot 4 positions, this is approach, pick, this place approach and place. the 4 points, we can go on and write the software. But before we write the main pick-and-place software, we want to exercise an auxiliary subroutine to reset the process. So we bring in a subroutine here. We redefine it as a reset part, and then we can bring in a command which is replacing the parts. Then we can use this subroutine later on. To write the pick-and-place program, we bring in another program, and it builds up on a list. And then we command the robot to move fast in a joint position to the pick approach, then move slowly to pick up the part. Then we want to attach the part to the gripper with this command. Then we beckon off to the approach position of the pick. Then we go fast with the joint positions to the place approach. We go slowly down to place it. Then we detach the part from the gripper, and we move back to the place approach, and we're done with the cycle. We finally call the reset part to allow us to start over. This is a simpler way. We could also add some wait functions command right after we place the part, or right before we pick the part, just to let things settle down. We can also put a command that changes the velocity in order to control the approach speed and the fast motion speed. Once we finish the positioning and writing the program, we could then simulate the program just by double-clicking the main routine, and it will trace through the points. We could add the trace just to visually show where the robot is going. And over here on the right-hand side, we can see the axis moving as the robot does the motion with a precise joint position. Finally, when we're done, we can export the program and send it as an HTML file to show the process to whoever we want. We will finish the report with writing these items in it, including these items in it, including the objectives as shown on page 2, the screenshot of the scene, and the target points as shown in page 7. And then we'll also like to see the software that you write, and as shown in page 10, and then the final simulation of HTML as shown is page 12. We will demonstrate now the software. We come here, this is the software that we saw before. We've added some wait time, and also some, we see over here that we have wait time and another pause of 2 seconds. And to run this, we could click that, and then we see the robot is moving. The reason why the initial one was because I probably messed it up, but you see the pick, the place, and there is some move time. We could also run it fast, just to check it. We can stop it and simulate that very slowly. As we move, we see that the joint over here showing the position where the robot links are located. So the final thing that we want to look at is the HTML, and we see a scene like this after we export that, we start it, and then we see the final process. This concludes our presentation, and we hope you enjoy the process of learning how to start with RoboDK. Thank you.